Um,
I imagined that exactly happened, but you know, this is a little bit more slightly perhaps less formal than FOSS. FOSS is not exactly formal itself, but this is going to be a little bit, these next few lessons are going to be a little bit more informal, and my hope is that we can make them a little bit more conversational, where we are here, this is a small group, and we can talk to one another regarding things that we don't understand, things that we may want to try. And all in all, this is a solid group which can hold on a conversation like that. Um, that said, this does follow the same setup as FOSS. So where is the chat? Here we go. All you need to do is go to the same FOSS website and now click on the FOSS Plus tab. Sharing my screen very quickly, the FOSS Plus tab is right here on the top, and it's going to bring you to a quote-unquote second home. And this is going to be our home for the next month or so. We are going to be covering reproducibility with a little bit more depth, going back and seeing containers once again, but now not only accessing containers, but also building them. One exciting thing is that next week we are going to be moving away, quote unquote, moving away from cloud, and we're going to be looking at the HPC here at the U of A. You may be already familiar with it, but keep in mind that there is people that are not, and that is a resource that we believe everybody should know that we have and know how to operate. The week after, Chris Reedy from UITS, he's the head of the HPC department. He will talk a little bit more on the HPC itself, talking about the structure of the HPC, how things run, because it's fun driving a car, but it's more fun knowing how it is built. And lastly, we're going to have a student from Data Lab coming in and talk a little bit about SQL or SQL and databases. This, once again, you may already know about it, but if you're working with big data, this might be something that is interest of you. The total expected outcomes over the next few weeks are going to be able to build your own container from a public containerized image, be able to deploy personalized images onto the HPC. They may not be personalized. Maybe we're just going to get to pulling images from the HPC, understand the HPC structure, and understand how to essentially use SQL and how it works. The lessons you can find under this little tab over here, and you can follow them along. Right now, only the first lesson is uploaded. If you go to any other lesson, you're going to be met with this little truck that tells you material is coming. Yay. So on to reproducibility free, building Docker containers. I want to check in with you because it's been a couple of weeks. Let me expand this window a little bit over here. I want to check in with you first because it's been a couple of weeks and I wanted to know what were your thoughts on containers. Did you understand them? Did you not understand them? Did you go ahead and try it out? I know Kurt has been building his own containers. I know Tuluwanimi has worked in Docker before, but I wanted to know if anybody else has had experiences with containers afterwards and if you have questions. And I'm going to give you a few seconds to unmute yourself, type your thing out. We're not going to be using a hackpad today regarding containers themselves. And if we don't, that is completely okay because we're going to go back and talk a little bit about containers. So I wanted to go back a second and talk a little bit about images versus containers because this is something that it's important to understand. When you are accessing through Docker Hub, so if you physically go to, oh, where am I? If you physically go to Hub, what is going on? Excuse me, my Zoom is not working the way it's supposed to work. Okay, here we go. When you go to Docker Hub, hub.docker.com, what you're seeing is a number of images, Docker images, and these can be pulled, modified, worked with, but an image doesn't become a container until it is expanded. So I went ahead and created a small table trying to answer the what, when, why, and where about what an image is versus what a container is. And the image itself is a snapshot of an application containing code, all the libraries, the dependencies, and files needed for a specific application to run. So if, for example, you take into consideration RStudio, all of a sudden you need R, you need RStudio. Maybe you're doing some analysis, so you may want to have ggplot installed. You may want to have some bioconductor repositories installed as well, whilst all of that goes into the container. Sorry, the image, the container itself is a runtime instance of the image. So you're taking the image from Docker Hub, bringing it down to your local computer or to your virtual machine, and then you're expanding this and creating a runtime instance of the Docker image itself. The image is trying to answer the when over here is created through something called a Docker file. And we're going to be looking at what the Docker files are today. So image comes first, you create the image first, and you essentially access the container after you create the image itself. Why you will want to do that? Well, both of these are reproducibility and consistency. You want to be able to ensure that your code is reproducible anywhere you go by anybody. And this is done through what we know until now, Docker, the Docker hypervisor. And where can you find images? In aligned registries such as Docker Hub or, for example, harbor.cypress.org, that is our private registry, or Quay.io. This is another registry which you can deposit and find images. We're going to look at Docker Hub and Quay.io soon. Oh, yes, and containers are executed onto your machine. Then I went ahead and created a small little diagram which addresses on paper when the image is created and where the containers are run. For example, the image itself is built locally or wherever local is from a Docker file, and this image can be stored online, or you can execute as many of these images, expand them into containers as many times as you want. And that is quite an interesting point of view because it's incredibly powerful. You can have the same program run as many times as you want. And at the same time, you can also put it away if you don't need it anymore. So what I wanted to do today is an exercise that hopefully will be lasting for the next hour, hour and a half or so. We are going to have a break in the middle, and and I would like to invite you to go back to the GitHub page that we created a couple of weeks back with Jeff. Have you ever found examples? Jeff has a question. Have you ever found examples where data is stored in a container? I haven't seen it, but seems logical. So I'm going to stop sharing a second. Containers aren't necessarily meant to host information, to host data. Containers are essentially your tool. You don't necessarily store nails in your hammer. However, there may be small enough nails which can be put inside a hammer. Containers are supposed to be these Docker images, containers are supposed to be very lightweight, such that they can be put somewhere on the internet, downloaded very quickly, and expanded onto your computer. I have added a small section today that we should cover today regarding managing data in a Docker container. So this is coming a little bit early, but the idea is you don't really store data in a container. You have the ability to, however, mount a local volume onto the container. This may sound like jargon, but trust me, it's a lot easier executed when you understand it a little bit more. So thank you for the question, Jeff. So what did I want to do? Yes, we are going to go back to 2 weeks ago's FOSS GitHub repositories. And for example, for me, it was github.com/my username/FOSS_S24_Docker. If you could please go to your GitHub and access that repository and then access the code space, then we are on par. Do let me know through reactions or through the chat whether you are there or not. I'll give you a minute. Yes, as Carlos says, mount equals a local computer directory that can be seen inside the container. Jeff, the one that we created 2 weeks ago, so you created a FOSS repository, isn't it? Where you pulled your PDAL. Git, yeah, okay, cool. And once you're there, just give me a thumbs up, please. Thank you. Kurt, I believe that is up to you because I believe people have saved the repos in different names. But if you do need help, this is the name of my repo, FOSS_S24/_Docker. Or you can just create a new blank repo. No worries, that's that's understandable. All we need is access to code spaces, or if you feel adventurous and have installed Docker on your computer, go ahead and do that. No problem. I'll give people still a minute. My code space is not starting up, so I'm still waiting as well. Good point. I should probably show you how to do that. I'm going to share my entire desktop as this is, you should be able to see a side-by-side window. All right. So in order for you to launch the code spaces, I'm going to reload the page. This is your repository. Make it a little bit bigger. And you see this big green button, you click on code, you may have local and code spaces. What you need to do is then click on either a plus, which creates a new code space, or if you do have an older code space that you have launched from here, you click on the older code space. And this should get you to connect, which for me seems like it's not working. So I'm gonna give it a minute, but if this doesn't start up, then I'm just gonna create a new container. Sorry, a new code space. I'm not happy with it. I'm just gonna go ahead and create a new code space. So once again, click on code and click the plus on code spaces. No problem. Is anybody else having trouble, or is it just me? Yes. Okay. So obviously things don't work when they're supposed to work. Damn, Brandon. Damn. Gotta move down to the Starbucks Wi-Fi. To the Starbucks for the Wi-Fi. I wonder if changing to edu-ROM will change anything. I don't want the connection to drop. Okay, well, I'm gonna approach the problem in a different way. Who here? Exactly, we did not have the same issue last time. Who here has Visual Studio Code installed on their computer? Please do raise your hand or give me a green check if you do. Okay, I see at least one person, two people, three people that have it installed. Today is going to be a little bit different than what I expected. So let's CodeSpace launch find for you. It might be a U of A thing then. Fun. Okay. I would like for you to, well, do a couple of things. First, go to Docker and docker.com and do download Docker desktop. You should be able to download for Mac or whichever. Okay, so we're not the U of A people are not the only one that are having issues. I would like for you to download Docker and install it on your computer. And you go to docker.com and install that. It will ask you to log in. I do believe that you have created some Docker credentials, and then go to VS Code, code.visualstudio.com, and do download that as well. Code.visualstudio.com. And once you have installed both Docker and Visual Studio Code, please do let me know with either a green check mark or a thumb up. This was not having an issue with me 20 minutes ago. It's so incredibly volatile. Docker itself should look like something like this, which is a desktop application. I'm just going to let it open until I see people being on the same page. And Visual Studio Code should be quite similar to the code space that you have installed, that you have access to online. So I've opened a couple of things, and the two should look like what you see on the screen. Okay, I see two check marks. Fantastic. Gonna wait for another couple. And then we can get going. No problem, Kurt. I echo you. I see you. Once again, Kurt, you are the one that probably has already created a Docker, so it's no problem with you. Sarah asks, what specifically do we need to download? No problem. I have posted them in the chat. The first one is Visual Studio Code. You can download from code.visualstudio.com. And essentially, this is an interface, an IDE, where you can modify code, but it allows you to have a very clean interface. And then please do download Docker, which is a hypervisor for images and containers. Having this installed on your computer will allow you to create Docker images from your computer, upload them to the Docker Hub, and that's why we need Docker installed. And Visual Studio Code is not necessary, but highly suggested. This is still connecting. So Brandon asks, is VS Code the preferred IDE? I hear good things about PyCharm as well. Also, containerization is a fun word. It is a fun word, but it sucks that there's only one word for this entire thing. Oh no, Sarah. If you can't follow along through the coding itself, I hope that's okay. But this will be recorded and made available to you.
No
Okay,
problem.
fantastic.
Like I'll try and I will definitely follow along. And my brain's a little bit full at the moment anyway, which is
No
I'm sort of
problem.
sorting out. But I will follow along, I promise.
Very much appreciated. VS Code is what I think a number of people in my immediate environment prefer. And sure, PyCharm is great, but I believe VS Code is a step above PyCharm simply because there is a bigger community around it. So I suggest it. Okay, well, it is 11:28. If you were able to either get a VS Code, sorry, a code space running VS Code installed or Docker, fantastic. If you haven't been able to, well, I hope that you are able to follow along. Okay, so I am going to go to my visual code over here, and I am just going to create a new file, or you know what, I'm gonna go and have a new folder just for this. So I'm gonna go to File, Open Folder, and I'm gonna create a folder on the desktop. Why not? And I'm gonna call it FOSS Plus, because heck, why not? Spring 24, and just gonna call it, and we're gonna create it, and then I'm going to click Open. This is going to, well, essentially create a completely clean VS Code project, I am going to say, do you trust the authors of these files and folders? Yes, because that is me. I don't know if I should actually trust myself, but this is what you should be able to see. A single clear explorer on the left with nothing much in it. The next thing that I do want you to do is to click this new file, start with new file, and I am just gonna, it's going to drop down a menu at the top, and I'm just gonna call it Docker file and no extension, so don't have to add anything after the dot. Just going to be called Docker file, all lowercase. Going to ask to create a file. Yes, please do create a file. It's going to be called Docker file. I'm going to also paste this in the chat. So a Docker file is essentially where you, I don't know if you can see my screen. Can you see my screen? Oh, no. Okay, cool. A Docker file is essentially where you write your instructions regarding what you want in your Docker, essentially in your Docker container image, sorry, in your Docker image when you run it as a container later on. And there is increase font, please, on both sides, Carlos. I'll do it on both sides. Left. Okay. Well, I did it to both sides. And a Docker file is a text file that contains a set of instructions, such as what you can see here on the right. I usually start with the from instruction, and the from instruction is what you essentially use to tell Docker, hey, Docker, use a specific image as base and build from there. I have written some instructions here on the right, so it tells the Docker file which image to pull from. In this specific case, we're pulling from the PDAL image. And as you can see, it doesn't have anything beforehand, and this is assuming that it is pulling directly from Docker. If you go to Docker Hub and type in PDAL, it brings you to the PDAL Docker build, which is quite barren over here, but this is essentially what it is pulling from. I don't want to go into too much detail because I may say something wrong here, but Jeff, I know that you are sick, but can you tell me a little bit what PDAL does? Can you tell us a little bit about what PDAL does?
Yeah, sure. Hey everyone, I'm a little sick, but I'm here anyway. So PDAL is a point data abstraction library. It's just software that analyzes point cloud data from laser scanning or from photogrammetry. And so I used it extensively for aerial imagery from drones. So that's what PDAL is. It's not very important for understanding Docker, but yeah,
Yeah.
PDAL is just a software that can analyze point cloud data. That's all it is.
Thank you very much, Jeff. That's exactly what I wanted to hear. Just a little bit of background on what this is. I'm not going to allow you to, I wouldn't let you type anything over there. So I just wanted some clarification on what PDAL can do. And what this does is essentially goes into Docker. It looks for PDAL, the PDAL repository, and then it looks for PDAL within that repository. And then here, if you remember from a couple of weeks ago, it pulls the latest tag. This ideally will be the latest version that they have uploaded. The next thing that we have on the instruction on the right is that you are instructing, or as Carlos likes to say, following the cooking recipe, you are instructing Docker to set the work there, so the working path within the Docker image itself, to be app. So what this will do is that it will set /app as the current working directory. I do not have pdal_copk.sh, but what the copy command in this specific case will do is to copy a local file and upload it onto the following directory. Same with the next line, copies a certain file from a local directory onto the app itself. Excuse me, the image itself. And then it runs this specific command, chmod +x, which allows for the user within the Docker image writing privileges. And this is what the +x does over here. But I wanted to go back to what we left it at last week, which is entry point over here. And entry point is the first command that is executed upon launching the app itself. In this specific case is asking for app_copk.shell, which would run the file itself, but it seems like we can't go ahead with this since I do not have the files themselves. That said, I did ask you to create a Docker file, but we're not going to be using the Docker file itself. We're going to be using Docker files that we have written already, and we're going to build upon them themselves. I have written here some instructions on what the entry point does, but we just covered it. And the next thing that I wanted to do was for you to please do git clone this specific URL. Git should be installed if you're using a Mac. If it is not, then, well, crap. But if you do go ahead and do git clone, I want to see what happens. And I'm understanding that I'm skipping a step here because I should show you where to get the terminal. If you are on VS Code, go up to View, and right here at the bottom, you see Terminal. You can click on that, and it's asking me to update my my terminal. I'm going to say no for now. However, it opens up a terminal which you can use for any sort of work that you want to do. I have pasted the specific command in the chat, so I'm just going to paste it over in the terminal. And what I'm going to do is that I'm going to git clone this specific repository onto my local computer. And it is asking me to do cd intro to Docker. I just auto-completed it by using the tab and pressing enter. As you can see, I am now in intro to Docker. I can also see that by doing print working directory, and it does show my entire path. And if you do look over here in the Explorer on the left, what is inside here, there is a number of folders, and within each of them, there is a Docker file that we are going to be using. So do let me know if you were able to get intro to Docker pulled from online, or whether you require an extra minute. And give me a thumb up if you are over here. Okay, Chris, you're always number one. Good job, Coco. Okay. Okay, so we got a few people that were able to get the intro to Docker, so we are going to proceed. Okay, the rest of the lesson is about figuring out what goes into a Docker file and how these Docker files work. over the past 10 minutes, we talked about what some of the instructions are, but what we still have to do is to create a functional Docker file. So I believe the next thing to do is to pick whichever one over here. Let's go for the easy one. So I would like to start with cowsay, because cowsay is pretty easy and simple. It will hopefully it will tell us a little bit of Fortune, cowsay, and lolcat. But what I wanted to do is go through the Docker file itself altogether. So please go into Docker and cowsay and look at the Docker file. Okay, so here, as we can see, the first statement is the from statement, and it is asking to pull Ubuntu 22.04. But there is an extra flag, and the platform that we are trying to pull is platform equal Linux/AMD64. This is because we are trying to pull a specific container that's able to run on a specific machine. This may or may not work if you have an ARM Mac computer. So what I am going to do is that I'm going to delete this specific line, but I can always add it later if I need to change it, if the Docker file doesn't work. So I'm just going to delete this, and I'm just going to say from Ubuntu. Let me see what the actual path is. This is easy enough. I can just go to Docker Hub, type in Ubuntu, and see that, well, all I need to do is Docker pull Ubuntu. So all I need to do is type in from Ubuntu, and I believe that the tag itself, I can do latest. Let's see if 22.04, there is a tag 22.04, so this should work. Take care, Jeff. Next, these are a number of labels, and labels are, they don't necessarily affect the building of the image itself, but they are important to recognize who is building the image. So if you can go over here and type in who you are, this will be extremely useful for the future, figuring out who has created a container. I'm going to type in my email, the version of this specific container. I'm just going to keep it as is. This is my first Docker file, correct? And today's date. Today is the 21st of March, the first day of spring. Happy spring, everybody. Okay, so if you have done from and the rest of the labels, then we can move on into what we want the app to do. And in the specific case, we want the app to run something. We want to install 3 different tools, and these are Fortune, cowsay, and lolcat. You can't see it because it's off the side over here. Let me make this a little bit bigger and this a little bit smaller. There we go. So if you are new to Linux commands, what is happening right here is that we are asking Ubuntu to please update, and this is the way that you say end, please. If this is successful, do the next. So this is more like an if statement. If successful, do the next step, which is apt-get install, and say yes to all Fortune, cowsay, and lolcat. The next thing that happens is that we set the environment path such as we're adding user games to the path. This is a little bit like Linux language, where you're adding to the path a specific folder, or you're adding, yes, you're adding to the path a specific folder. And this is just an internal such that the software itself is going to be able to run. I believe you can get away with not writing this, but ideally, what we expect out of this Docker file is that a fortune is going to be put inside a cow that is going to be put inside an LOL cat. If you're new to Linux, these are pipes, and pipes take the output of the first command, pipe it, put it essentially into the second, which put it into the third. There isn't much to change at this point, as in we had to create this. You will have to write all of this first and then run it. And this is going to be ideally your first Docker that you build. So how do you do that? Let's assume that the Docker file is written. The next thing that you have to do is to change directory into the specific directory. And right now we are in cowsay, so cd into cowsay, and then press enter. And here, you will have to do docker build dot. And what this command will do, where is everybody? Yes, is that it's going to say, hey, Docker, build from the Docker file in here. This could also be docker build Docker file, but I'm just going to say docker build dot. Then I'm going to press enter. And if you do have Docker installed, this is what you should see. And I'm going to go through what is going on, what you're seeing right here. So as you can see, there is a 1 out of 2 and a 2 out of 2. And these are essentially what these are the steps that Docker sees that you should run. And the first one is creating from, and the second one is running this specific command. If we had added a second run command, then Docker will recognize it as a third step to do, but everything else, such as label, environments, and entry points, these are quite easy to execute. Once it is finished, it should end with something like this: write image and then a SHA. How do we check whether it is completed? Well, we can do Docker images. Oh, I have many that are still running, that are on my computer. But if you do Docker images, I'm going to make this again a little bit bigger so I can see better. I can see that there is an image over here that was created 23 minutes ago, which is roughly 203 megabytes big, with no repository name and no tag. Okay, this is kind of what I'm looking for. And before we continue, I just wanted to see if you are here or not. Give me a thumb up if you were able to create your image. And if you do Docker images, does something like this show up? Okay, great, Coco. Okay, fantastic, Chris. I'm going to continue ahead then. Since we do have this Docker image created, all I need to do now to run it is to do Docker run and then the image ID. I don't have to write all of it. I could also decide to run it by its name, but it does not have a name and it does not have a tag. So I can run it by the image ID. And I know that 55 is unique enough. So all I need to write is Docker run 55, and hopefully this will give me my fortune for the day. And that's exactly what I was looking for. How many watts does it take to change a light bulb? 1. It's not so funny. I'm sure that was said in this specific. Okay, thank you, Brandon. I'm sure that this is supposed to be a specific joke that I do not understand. So I'm just gonna run it again for a different joke. Tuesday is the Wednesday of the rest of your life. I don't know if that's funny. What does it mean? There's probably a lost in translation that I don't know. This used to be a lot funnier in the past. I don't know why this is not as funny. I thought the highest point of all. Oh, I've touched the highest point of all my greatness, and from that full meridian of my glory, I haste now to my setting. I shall fall like a bright exaltation in the evening, and no man see me more. Well, Kause, I'm gonna tell you, you're not funny anymore. If you do, it's a fortune cookie. Yes, Carlos, but it's not funny. Or it is not fortunate. I don't know. This is not what I expected. Regardless, what you have now is essentially a functional Docker container that you have created using a Docker file. You could essentially go ahead and do whatever else you need to do. For example, what if I don't like the fortune that I'm seeing right here? So I'm just going to go and delete fortune from the things that I want. And because I have removed it from the run statement, I might also want to delete it from the entry point. So I'm going to go ahead and delete that from the entry point and as well. Save my Docker file, and then I'm going to do Docker build, and then dot again. It's not my first Docker file, it's my second Docker file now. I'm gonna save this, and then I'm going to press enter. And I'm gonna do, and it's gonna do almost exactly the same thing as before. Just that, as you can see here, it recognizes that there is a cached image that it pulled from earlier. So just be careful with pulling images because they end up caching and they end up inflating your computer. Just checking that it was not cached from this one is not also cached. So all I'm showing here is that it does cache and it is recognizing that there is a difference in the second step, and therefore it is running that second step again. A question will then be, so what if the second step would be the same? What would happen? Well, it would again access that second step through the cache. So I'm going to do Docker images. And now I can see that there is a second new ID that I didn't see before. So I'm going to do Docker run E7 and press enter. Oh, and now I definitely do not have fortune. So I don't know if that was better or for worse. But this is a really simple example of how you can go inside a Docker file, say something isn't going the way that you like it, modify it, and then build this Docker file again. I'm going to now add a third statement, which is going to be, I'm not really sure right now. Fortune E funny, not funny. Okay, heck, let's do that. Apt get install fortune, and it's going to download it again, but I want for you to understand that it will have created cache for the image and the second step. Now it should only run the third step. And I'm going to say fortune. You say doing dash E, funny,
Environment.
no,
Yeah. Funny,
funny.
not funny. 50%.
Okay. Well, let's see what happens if I do that. So what the changes I've done is I've added a third statement and I'm adding an extra instruction in the entry point. Once again, I'm going to save my Docker file and ask Docker to build. I can't spell. So Docker build dot enter. And as you can see, oh, is running into an issue where it has found an error itself. Oh, you know what it is? I did not add the dash Y, and this is where I tell Docker to install with a yes. So I'm just going to add dash Y, and this should run. I'm going to save my code and press up and ask Docker to build again. As you can see, it was now cached. Everything until here is cached, and it's just running the third step. I am going to do Docker images once again to check on images to check the third image ID created 17 seconds ago, free F. So I do Docker run free F. Press enter. No fortunes found. Fantastic. That's not nice at all. What if I run it again? No fortunes found. Not funny. Well, that's not very nice. It's a 50-50 chance, you said. So if I keep on doing it, well, that did not go as I expected, but welcome to debugging with Docker.
Take out that sheet, see if it works.
Take out the dash E and see if it works.
Yes.
Okay, I once again have to do this, but this should be a lot quicker. Docker images and D4. So Docker run D4. No fortunes found. Well, that's okay, because what this exercise allows us to see is that you can go into a Docker file, modify specific things, and recreate the Docker as you need. So this step might sound incredibly tedious, annoying, and honestly, just not something that you want to go through. But this is going to save you time in the future. Why? Because all of a sudden, imagine yourself telling to your coworker or telling to your collaborator, oh yeah, no, install Cowsay, install LOLcat, install Fortune, and they don't know how to do that. All of a sudden, you are saving so much time, maybe not for yourself, but for somebody else that wants to run your code and may not have as much of an expertise that you do. So this is quite a simplistic example, but it can save you or your coworkers so much time in the future. There is something in the chat. Kurt says, a typical of light bulb jokes, the answer is nothing wacky. It is quite simply one, but it's telling nonetheless. The stereotypes of white Anglo-Saxon Protestants, particularly of those of the affluent variety, is, of course, that they do everything in the proper way. But it's still not funny. Correct. Okay. So it's 11:59, and we did go through the very basics of building Docker files. I am going to call for a small break. So let's meet back here at 12:10, where we're going to talk Docker files and building Docker files and what to do with those into slightly more details. Enjoy your 11-minute break. I'll see you soon. All right, it's 12:10, and I would like to ask whether there are any questions regarding the Cowsay Docker file. And if there aren't, that is completely fine. Want to go and share my screen again. Minimize this. All right. So coming back, I wanted to see how far we've gotten. And we did go through a number of steps that are in the notes themselves. So how to write a Docker file, how you can create a Docker file, and what the from command is, what platform does, what labels are, what run what the run instruction does, what environment does, and there also is an explanation of what the LC all does, and that is locales or locals. And what copy essentially does as well. We did not cover what CMD does, and CMD is an alternative to entry point. Whilst entry point is your default CMD, essentially can also act as what you should run first, what you telling the computer what you should run first, not the computer the container. However, it does give you perhaps a little bit of a different syntax. And if you do want a little bit more on which one you should do and use, there is a small little expandable over here. I do suggest you, however, keep using entry point until you're okay with trying to use command, because that does require a little bit more understanding of Docker files in general. What we have not covered are user, expose, and these two allow you to set essentially what abilities, what can the user do when it's inside, when you're operating a Docker container. We're going to be seeing soon over here, we may not need to actually, but I'm still going to mention it, that in the Jupyter example that we're going to run later, we can essentially we can add a user and change what the user permissions are. And as you can see over here, there is an example regarding Ubuntu. You are setting the user as Ubuntu, and if you know what that means is that, well, Ubuntu runs fine, but if you were to set, and if you were to ignore this line right here, if you were to set the user as someone else, you may not have as many permissions. So you may need to go through adding the right user and giving the user the right permissions. And then we did talk about ports last time around. We do know that, for example, for Jupyter, the ports that it likes to use is 8888, for RStudio is 8787, but your Docker image, your Docker container won't run if you do not expose a port if that container needs a port open. For example, if we go to, I'm going to close Cowsay. If we go to Intro to Docker and Jupyter, it's going to go into Minimal Notebook directly. You can see that there is 3 statements here where it asks for from Jupyter Minimal Notebook. I'm going to say latest over here. I don't know if there is a latest. Let's go and check. I'm going to go to the hub and check for Jupyter. And we are looking for minimal notebook. What happened? Whoa, what's going on? There we go. Minimal notebook, tags. And there is a latest tag uploaded, last pushed 5 months ago. And it's asking, and the next thing that we do is copy model.py in home Jovian work. If you do not know about Jovian, well, that is essentially the user, the standard user for Jupyter. So it's copying a local file, model.py, into home Jovian work, and then exposing the port itself. So if you look at model.py, well, it's a simple, very short Docker file, sorry, Python file, which essentially says if you run it, return hello plus the name itself. Let's see if that works out. I'm not going to change anything right now, but I do want to go back here and remove the expose and see what happens. One thing to keep in mind that this is different than the Cowsay example before, because this is going to run an interactive Docker container, an interactive image that then expands into a container, whilst Cowsay, it was just executable, and that is a difference that's worth knowing about. So I'm going to change directory into Jupyter, and I just type in Jup, and then press tab, and then I know that there is only one here, one directory in here, so I'm just going to press tab again and press enter, and all of a sudden I am somewhere else, and I can do docker build dot, and it should be completely fine, as these are the only small instructions that I have. It is now getting the Jupyter minimal from Docker, and this might take a second. It is definitely taking more than a second. Oh, there we go. It is copying the model.py into home Jovian work. And it is done. Just asking how many of you are following along, and were you able to get to the same point? Do give me a thumb up or a green check. Okay, that works too. Thank you, Coco. Okay. Coco's following along. That's good enough for me, and Chris as well. So once again, I have created a new Docker image. I don't know the ID, so I have to do Docker images and go and fetch the latest, which, as you can see, it's quite much bigger than the ones that we have created before. And it has a 00, so I believe I can just do Docker run 00. Now, this is going to fail. Actually, no, this is going to run, but this is not going to be doing what we're expecting it to do. And what we're expecting is that we should be seeing a page opening, a token, and whatnot. But this is going to fail. And it's going to fail because we have not told Docker to listen to port 8888 in the Docker command itself. So first, I want to run it without the port option. As you can see, it runs. No problem. Fantastic. Great. But if I were to copy this URL, go to my browser, paste the URL, nothing is going to come up. It's going to actually say, hey, nothing, broken, site can't be reached. So if I have to go back, if I go back to my terminal and press Control-C, and then press up, and do docker run -p, which is the extension for port, 8888 colon 8888 space. What this tells the computer to do, what this tells Docker to do, is that it should listen to port 8888 coming from the Docker side and coming from the computer side. The computer side is on the left and the Docker side is on the right. Question, can the port on the left be different? Yes. However, my suggestion is to stick with the same port as the one that you're exposing from Docker. That said, I'm going to press enter now, and it's going to give me the URL, which I am very happy to copy and go paste. Oh, hold on a second. I think I pasted it twice and paste. And it's still telling me that there is a problem. That is not good. This is not what I expected. I'm going to paste it, take the other URL and paste it over here. Ah, there we go. Much better, much, much better. And all of a sudden, we are inside a running Jupyter. And if we go into work, we should find the model.py in there. And there it is, model.py. Fantastic. I can open up a terminal within my Docker container. So this is only within Docker. I can do whatever I want in this instance of Jupyter, and it won't affect my computer. So we are going to do Python. Actually, we are inside work, so I have to change directory. Oh, wait, if I do list ls, okay, model.py is already there. So I just have to do Python model.py. What happens? Nothing. Model.py, and then I actually give you the name that you are expecting, I believe. There we go. So what happens if I write Michele here? Nothing. Why are you not running? Maybe, just maybe. Yeah, okay. Permission denied. That's okay, no problem. The example is that doing the copy allows you to get a file from within your computer onto the app itself, onto the container itself. And you can do more with it. You can add and you can remove. So I'm going to stop the container and it's going to give me server error. So what happens if you remove this? I'm going to add a hash, and that is called commenting out. So I'm removing the expose 8888. I'm going to save, and I'm going to tell it to build the image again without the exposed port. And that was very fast. So I'm going to go back to do Docker images. See the latest image is still 00. Wait. I'm going to do 05 because I know that the 00 was the one that we built previously. So if I do Docker run, and I'm going to say, open up the port 8888 and listen for 8888 and do run 05. What happens if I copy this, go over here and paste? You're not supposed to run. Why are you running? Oh, I know why it is running. I know why it is running. Do you know why it is running? This is going to be a question for everybody. Carlos, you can also answer if you want. There is okay, I'll be honest with you, I'm not really sure exactly why it is running, but I can for sure say that because the change was small, or wait, maybe. Let me see a second. Just give me a moment, please. Thank you. This is my hypothesis. Oh, there's chat. Did you kill a container when you close the browser tab? That was my first thought, Kurt, and I did Docker PS. It seems that it was dead. Brandon says, did you say something earlier about it being an interactive build? This is an interactive build. Regardless, that doesn't have any connection to why it is still running. I think why it is still running is because the cached from copy also include expose 8888, but I am not sure. That said, I don't know if typing in an extra run command, and all I'm going to do is do apt get update. That's it, use cache, Docker build, no cache. That is, yeah, Kurt, that actually is a command that we have not covered before, but doing no cache will, well, will not load it in cache. The love of Docker, for the love of Docker, Docker build. Going to run an extra run command.
Yeah.
What? Upgrade. I'm going to do just upgrade.
That should be done before.
You mean I should move the run command above?
Yes, before you start.
This is the love of Docker. Everything breaks all the time. But once it works, it works. A terminal is required to read the password. Either use the S option. Okay, so fun. Sudo is requiring the password. What if we remove sudo? And this is why you should read your error commands. When it works, yes. And now it says that permission are denied and I should be root. Fantastic. We do have a problem. So I'm going to bet that if I set user Jovian over here, actually user root over here, then it is going to be able to go through the upgrade, and then I'm going to do user Jovian over here. Is going to set it back to the general user. I wonder if that is going to work out. So I'm going to say Docker build, go ahead. Oh, look, all of a sudden it worked. So this is what we talked about earlier. Setting the specific user can very much allow you to do things that otherwise you wouldn't be able to. If I were Jovian the entire time, which I was, the Docker wasn't able to access sudo commands and therefore run the upgrade command. Now that we have created the Docker container, Docker images, I want to see what the difference is. Seems like that there is no difference, and I am going to hope that I'm able to show you that expose is very important. So let's do that. Docker run, what was it, BC? Yes, Docker run -p 8888, and I'm going to try it without, I'm going to run it like this and see what happens. BC, gonna press enter, and I'm going to see if this works. Kurt might be very right here that I should build without cache, but I'm going to copy paste this, and I'm still able to get in here. This is not what I'm supposed to show. Docker build -- no cache.
What if
And
you remove all the previous images? from, all these unnamed images.
I can do that. I can do Docker RMI -f, and this is what we learned last week. The Docker RMI -f is incredibly powerful and remove all of the images. I wonder if I can do star.
No.
What is this? Invalid reference repository must be lowercase. What if I just do this? No, it needs at least one argument.
The purge, can you use the purge?
Yep, I'm going to do that. Docker purge -f. What if I just do Docker purge? Whoa, what do you mean it's not a Docker command? Docker images purge. Excuse me a second, I have to Google this. Docker system prune. Excuse me, everybody. It's Docker system prune. And we've seen this a couple of weeks back. This will remove everything. So I'm just going to go ahead and continue and delete everything that's on my computer. Total reclaimed space 268. Docker images, they're still here. Fantastic. That's not what I wanted. Docker RMI -f, and these are all of the images that have been tagged and whatnot. I'm just going to remove them one by one. So F3, 5D, 04, 6EC6, 4C. Just going to remove these for now. Chris, that is bloody smart. I'm going to do that. Things never work when you're under pressure. So I'm going to do Docker images. They're still running. Oh, there is still some that are present. So I'm just going to copy Chris's command and paste it. And for the ones that do not know what's going on is we're essentially telling Docker to remove images, but instead of writing everything down, this next command is telling the computer to go and pick images set by their ID. Exactly, Robert, exactly. And look at that. Thank you very much, Chris. That is incredibly helpful. If I do add a -f, then everything should be deleted and forced out. Okay, so now I can go ahead and do Docker build. There is no cache, so I'm just going to say Docker build from here and see what happens. Okay, it is building. Fantastic. And if I'm still wrong, well, heck, I'm still wrong and I don't know why. So whilst this gets built, what we have seen so far is what essentially could be very useful for you, where, okay, what if you want to run something on Jupyter? Well, you go to see on a public repository whether there is a Jupyter image that you want to look at. In this specific case, Docker Hub has a number of Jupyter images that are useful for you, Ubuntu images, Python images. Quay.io is also another repository that I mentioned earlier being important. And the reason why I wanted to go back to it is because recently Jupyter has chosen to host their images on Quay.io rather than, excuse me, Docker Hub. So if I type in Jupyter here, excuse me, gotta make it a little bit bigger. I want to see whether, what if I search it in here? Jupyter. No, it's the same thing. Let's say Jupyter Quay.io. Okay, well, it brings me to the Docker stacks, to the Jupyter Docker stacks. This is kind of what I want to see because it should then tell me where the Jupyter images are. Quay.io/Jupyter. Quay.io/Jupyter. And as you can see, it brings me to the organization where all of the Jupyter's Docker stacks are. So if there is something that you're interested in, here are your Jupyter images. You can do searches in Quay.io or Docker Hub. Not others are coming to my mind right now. And then you can add your code. You can use the copy command to add your code. You can change the user if you necessitate to. For example, you can add sudo abilities to Jovian so that you don't actually have to be root, and all of a sudden you can build on that Jupyter code that someone else has built. But going back to our example here, Docker images, there is an E19, and let's see if this, not Docker, excuse me, haha, Docker run E1, okay, and there is no port. Oh, let's expose the port 8888, 88, 80, 8888. Enter. Let's see if I'm right or if I am wrong. I'm even going to open up an incognito window and then paste this in. Holy crap, it's still finding the Jupyter. I have no idea. I have no idea where this is coming from right now. But that expose, maybe it's already being exposed in the base. So there is maybe no need to actually write expose 8888, but that is bothering me a little bit because regardless, it's an important step. Being able to expose and understanding what ports are when it comes to interactive containers. Okay, so that being said, we have learned what the user command does in the second example, what the run does in the first example, and what from does in the first example, and what the copy does in the second example. There is something else that I wanted to talk about before we go, and that is volumes in Docker. Let's just say that you, and this goes back to what Jeff had mentioned earlier. How do I access my data? Do I just add it? Do I add all of my data into a Docker container? No, you don't do that. And the way that Docker likes to access data is three ways. The first being volumes. The second being, just going to call it by what it is, TMPF's mounts, and then the third is bind mounts. I don't necessarily want to go deep into what the mounts are, but if there is a take home that I want you to have is how to access volumes. Volumes are essentially a virtualized version of a specific directory that you specify in your Docker command. For example, I want this entire directory to be seen within Docker itself. I don't want, however, there is no way for me to copy the entire, let's just say that there is no way for me to copy the entire directory onto Docker, and I don't want to do that. So how would I be able to access this container from within Docker itself? Well, you do that by doing a volume mount. you can use the -v flag when you run your Docker container. So you do Docker run, you expose the port 8888, and then you tell Docker, hey Docker, create a volume mount between and my folder and the destination folder. So for my folder here, I want to, for example, tell it this specific path. So I can either do dot, but I'm going to do $, pwd, which should tell it this specific folder, and the destination folder, which I am going to be copying from here. So home/Jovian/work. My expectation at this point is that I'm going to be able to see Dockerfile and model.py, and maybe let's add another empty file, empty.txt, and ideally I will be able to see empty model.py and Dockerfile within home Jovian/work. And let's add another one, mounted volume. So I should be able to see also mounted volume. And I'm going to start with that. I do not remember I think it was BC. No, it's E1. This is my Docker run command. I'm going to copy and paste this into the chat. And let's see what happens. I'm going to press enter. I'm going to copy the URL that it gives me and paste this in here. I see work. What happens if I click on work? Hey, what is that? Mounted volume. Fantastic. I can access mounted volume and I can see all of the files that are within this specific folder within my running Docker container. I can open these files. I am editing this empty file. Empty no more. And I'm going to save it. And as I modify things within my container, I can go to the empty.txt file and I can see these same changes being reflected on my computer. So all of a sudden, you could have a Docker file built, send it to your collaborator, and ask your collaborator to create a good reaction, Coco. Thank you. And you could ask your collaborator to create a mounted volume and edit their file using the code that you wrote to their files. And so your collaborator doesn't actually need to write any of the code or doesn't need to have the abilities to write it. They can just go ahead, run the code, and save it locally. Do see that it had a new folder has been created. It's called IPython notebook checkpoints, and these are essentially the changes that you make. The more changes you make, the more IPython notebook checkpoints there are going to be. This is not a Jupyter thing. This is just a this is not a Docker thing. This is a Jupyter thing. So with that in mind, volumes are incredibly powerful, and you can play around. So hopefully, and I think it also goes the other way around, where I can add changes locally too and save it. Let me see if I can reload this page. Let's see what happens. It goes two ways. I am surprised myself. All right, that was my little example of volumes. Okay, so it's 12:45, and with that in mind, I'm going to stop my little Docker container, and work a little bit on the Docker image itself. I know that, oh, excuse me. I know that Docker images, if I do Docker images, my image does not have a name. It does not have a tag. So my point right now is that I want to take my image, assuming that this is my final image, and I want to put it in my Docker Hub page. So how do I do that? Well, first of all, I'll need to log into Docker. So I do Docker login, and it's going to ask me for my username. It's called Michele, and my password, which is this, enter. Login succeeded, woohoo. Logging in with your password grants you terminal complete access to your account. Thank you, Docker. But that's the first step. You first log in into Docker. And the second thing that I want you to do is to add a name to your Docker image that you created. How do you do that? You do Docker tag, and then you essentially give it, you select the image that you want, E1, and then you tag it how you want it. I want to say minimal Jupyter, and I want to add a colon, and that should be adding the tag. And I want to call it, I'm going to give it today's date. So 2024, March 21st. I'm going to press enter. And if I do Docker images, you can see that the repository has been created, the tag has been added, and the image ID is still unchanged. That means that I can still run the Docker with E1, or I can type in minimal Jupyter, and that will also run. So we have logged into Docker Hub. We have changed the tags and the name of the Jupyter. And now all we need to do is do Docker push minimal Jupyter 240321. And hopefully this will send it all the way to my Docker Hub. Press enter. Requested access to resource is denied. That's why. The push refers to repository docker.io library minimal Jupyter. What does that mean? Well, that means that having repository minimal Jupyter, it's not good enough. I'm going to do Docker images right here. I need to change that to my own repository name. So I need to do Docker tag, and then I'm just going to do E1. I'm not going to write minimal Jupyter, yada, 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 because I'm going to type Cosi Michele / minimal Jupyter with an underscore, colon 240321. I'm going to press enter and do Docker images again. And now you can see that there is two repositories with two, the same tags, and these are the same images. But I need you to understand that this is really important. Having the repository name changed is going to hopefully allow us to send it all the way up to Docker Hub. So if I do Docker push, Cosi Michele / minimal underscore Jupyter 240321, and then press enter, all of a sudden it's running. So make sure to follow this specific convention when pushing and tagging specific containers. It's going to take a little bit of time. It depends on how fast your internet is. So I'm just going to wait a second. And by the way, do not do Docker push Cosmic Michele, do change it to your own Docker account. Oh, there we go. Oh, as you can see, it did find a essentially the same piece, the same hash for a specific part of my push into another image that I had. And it seems to have pushed all of the different pieces. Going to make this window a little bit smaller, and we are gonna go to my own Docker Hub repositories. And there it is, Cosmic Killer Minimal Jupyter. It was pushed a few seconds ago. I'm not paying for advanced Docker Hub, but there is more things that you can see. But essentially, that is how you are able to go all the way from building a Docker Hub, making all of the changes, adding, excuse me, testing it out, adding specific files that you require, to pushing it up to Docker Hub. And I believe this is available for everybody to see. So if I really very much wanted, I could send this to all of you and you all could download it. And that is extremely powerful when it comes to what do you call it? Reproducibility, because now you don't have to think about, I'm going to stop sharing, but now all of a sudden you don't have to think about your collaborator having to write a piece of code. This is all of a sudden, hey, Carlos, please go and download this repository, and you can mount your volume and you can work with the data that you have. Let me know if it works out, full stop. No one has to write any code, and it makes things extremely reproducible. I believe this is all of the material that I had for today. If we did have a little bit more time, I would have wanted to ask you to go and find your own Docker container, Docker image that you want to work with, modify it such that you have some changes that, for example, installing a specific program that will better reflect your own work, and then push it onto the any repository. But regardless, I think we did cover a lot today, between how to build a Docker all the way to how to push a Docker container, as well as making your files visible to the Docker. With that said, do folks have a question or two or none? Anything is good. Were you able to send your Docker from your local computer to the hub? If you have, give me a thumb up. If not, that's completely fine. And that's it for me. Thank you very much for your attention today. I'm glad Coco and Chris were able to get it up. Carlos, I know you can do it. Robert, I don't know if you have background in containers, but I know that you have background in SQL. So if you did follow along, thank you very much. And Carlos, yes, you have a question or a
No,
comment?
just thank
No?
you. Was
Okay.
nice hearing about Docker again. I know.
It's less fun when you have to do this every day.
Yeah, I know.
All right, folks. Thank you very much for your attention. I'll see you guys next week with the HPC. Oh, I believe all of you are, apart from Kurt, are part of the University of Arizona, correct? So you may receive an email saying that you've been added to the Data Lab account for the HPC. If you didn't, do let me know early on next Thursday. If not, all is good. That said, have a great week, everybody. I'll see you next Thursday. Ciao.